Terrifying today. There's going to be an eruption. Concerns grow as magma shifts beneath Yellowstone's supervolcano. Magma deep beneath Yellowstone is slowly moving northeast, a new study suggests. Yellowstone's massive caldera sits beneath parts of Wyoming, Montana, and Idaho, but the new analysis finds that the magma reservoir in the western part of the caldera is fading, while the reservoir of viscous rhyolite magma has shifted northeastward. While the reservoir beneath northeastern Yellowstone could hold enough magma for a caldera-forming eruption, none of the reservoirs are likely to erupt anytime soon. Yellowstone has had 3 caldera-forming eruptions in the past 2.1 million years, with the last one occurring about 640,000 years ago. The eruptions got their name because they spewed out such a large amount of lava that they collapsed the roof of the magma chamber beneath the volcano, forming a basin-shaped caldera. Smaller eruptions, the last of which occurred 70,000 years ago, have occurred in between these major events. Previous studies have used seismic data to assess the magma storage beneath Yellowstone and have found evidence of magma beneath the entire caldera. However, seismic data can be affected by the temperature, pressure, and volume of the magma, making it difficult to discern the true spatial distribution of the magma. In the new study, published in Nature, the researchers turned to a methodology known as magnetotellurics to more accurately map the extent of the magma beneath Yellowstone. Magnetotelluric instruments measure electrical and magnetic variations in Earth's crust. The liquid part of magma, known as melt, tends to be more conductive than the surrounding rock, so collecting magnetotelluric data across the caldera allowed the team to map the distribution of melt beneath it. We wanted to use this technology to see if we could improve the constraints on the melt bodies beneath Yellowstone, the locations of the melt bodies, and maybe even the composition and evolutionary state of each of these melt bodies, which is really quite a magical thing, said study co-author Adam Schultz, a geophysicist at Oregon State University. The magnetotelluric data revealed several small, isolated magma storage chambers beneath Yellowstone. The 2 largest chambers, likely filled with low-viscosity basaltic magma, are located to the southwest, between 20 and 50 kilometers underground. Farther northeast, smaller chambers form the largest reservoirs of high-viscosity rhyolite melt in the caldera. The chambers occur at shallower depths, between 4 and 20 kilometers. It will likely be years before complete reservoir maps are available for other large volcanic systems in the United States. To obtain high-resolution magnetotelluric maps of Yellowstone, the team had to set up more than 100 measuring stations inside the caldera, a process complicated by protections in place in Yellowstone National Park. I think it took us about 2 years to get permission to go out there and do this, Schultz said. Combining magnetotelluric data with other datasets, such as data from seismic and geothermal studies, could also improve understanding of the volcanic system, Schultz said. Right now, we are just at a phase where we can make the leap from geophysical imaging to concrete geological constraints, and those constraints will be even stronger if we can move from isolated interpretation of one type of geophysical dataset to combined modeling and interpretation of as many datasets as possible.